In this video, we're going to talk about properties of logarithms. Okay? So if m, n, and a are positive real numbers with a not equaling 1, and x is any real number, then, okay, so let's go through each one of these on an individual basis. Okay? So let's start with the work for number 1. Okay? So we've got log base a of a, right, is equal to, well, let's call this question mark. Okay, now I can write this as an exponential. Okay, so that's a to the question mark is equal to a. Okay. Well, the only thing that makes sense in this particular case is question mark is equal to 1. So log base a of a is equal to 1. Okay, okay, now let's go for number 2, the work for number 2. Okay, and it's saying log base a of 1, okay, and again we'll put equals question mark. Okay. Similarly, number 1 I can write as an exponential. A to the question mark is equal to 1. Now, the only time that is a true statement is when question mark is equal to 0. So log base a of 1 is equal to 0. Okay. Now, let's go to the work for number 3 then. It's saying log base a of a to the x. Okay, again, I'm going to put question mark. And again, similarly to the previous 2, I'm going to write it as an exponential. So that's a to the question mark is equal to a to the x. Because this is a function, we know there's only one answer, and the question mark in this particular case is x. Okay, so I'm going to scroll back up and fill in the first 3 answers. Log base a of a is 1. Log base a of 1 is 0. And log base a of a to the x is equal to x. Okay. Okay, now I'm going to go to the next page then. Again, I'll come back and fill in the rest of these. Okay, but let's go to the next page and do work for number 4 then. Okay, now for number 4, remember, we know that f composed with f inverse of x is equal to x, and f inverse f of x is equal to x because they're inverses of each other. So let's do this then. Let's do f of x is equal to a to the x, and g of x is equal to log base a of x. Okay. So now I'm going to do the composition f g of x. Okay. Well, according to what I've written, g of x is log base a of x. Okay. Now remember, every time I see an x, I'm going to replace it with log base a of x. Okay. So then that is now this. Okay. And again, because a to the x and log base a of x are inverses of each other, okay, I know this particular answer is going to be x. Okay. So now we know that. Now, let's talk about an example of number 5. Okay. Let's do log base 3 of 81. Now, we know log base 3 of 81 is the same thing as log base 3 of 27 times 3, because 27 times 3 is 81. Now, what I would like to do is to separate those 2 logs. Okay. So I'm going to put log base 3 of 27, and I'm going to put log base 3 of 3. Okay. Okay, now, log base 3 of 81. Well, that's in other words, I'll write on the side here, 3 to what power is equal to 81? Well, that's 4. Okay. 3 log base 3 of 27. That's the same thing as saying 3 to what power is equal to 27. We know that's 3. And we just finished talking about log base 3 of 3. We know that's 1. Okay. So now, what basic operation can I put in between those logs to make it a true statement? Well, that's addition here. So when I have the multiplication of logs, such as this, again, I'll go back to the original and rewrite. If it's multiplication, I can separate them with addition. Again, notice the bases must be the same in order for this to happen. Okay? Just like when you multiply exponents, you add the powers. Okay, so let's do an example of where it's division to start with. Okay? So I'm going to do now log base 2 of 32. Well, that's the same thing as log base 2 of 64 divided by 2, because 64 divided by 2 is 32. Okay? All right, so again, I want to be able to separate this. Okay? Okay, so we know 2 to the 5th is equal to 32, so log base 2 of 32 is equal to 5. 2 to the 6th power is 64, so log base 2 of 64 is 6, and we already know log base 2 of 2 is equal to 1. So now, similarly to what I just asked a minute ago, what basic operation can I put in between the 6 and the 1 to equal 5? In this particular case, it is subtraction. So if I have a log with division, and I want to separate this, okay, then I know it's going to be subtraction in between. And again, keep in mind, the bases must be the same. Okay, so let's do something similar for number 7. Now I'm going to write out literally the original part. Okay? Now, an exponent is nothing more than repeated multiplication. So I can write out this and do m times m times m dot 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 m p times. Okay? Now, we just figured out from 2 examples ago when it's multiplication, I can separate them by addition. So it is log base a of m plus log base a of m plus dot 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 log base a of m, but that's p times. So when you're adding the same exact thing p times, it ends up being p on the outside, log base a of m. Okay. All right, so now let's go back to the first page for this and fill these in as such. Okay, so first of all, for number 4, a, taking the log base a of x is x. Okay, for x greater than 0, domain restrictions. Okay. Log base a of m times n is the same thing as log base a of m plus log base a of n. Okay. For number 6, log base a of m divided by n is the same thing as log base a of m minus log base a of n. And for number 7, log base a of m to the p power is the same thing as p times log base a of m. Okay, so all of these properties are nice to know, but we will be using a lot of 5, 6, and 7 for later videos, and we'll take a look at the first 4 more in this video. Okay, so I'm going to skip to the 3rd page now, okay? And now I want to be able to simplify the following. Okay? So log base 69 of 1. Well, that's similar to property 2, where log base a of 1 is equal to 0. So log base 69 of 1 is 0. Okay, common log of 10. Remember, that's the same thing as log base 10 of 10. That's very similar to property 1, where log base a of a is equal to 1. So the common log of 10 is 1. All right, log base 7 of 7 cubed. That's very, very similar to the 3rd property, where log base a of a to the x is equal to x. So in this case, it's 3. Now, this last one's a little bit more involved for this. It's using property 4, but it's not quite there yet because of the 2 that is on the outside. Now I can use property 7 because I have a number on the outside. I could put it back inside the log. So I can rewrite it as this. Okay. Well, we know that's going to be 25. And now I can use property 4 directly. 12, taking the log base 12 of 25, that's equal 25. Now, because natural logarithms are special type of logarithms, I know these particular properties quickly also. So for instance, the natural log of 1. Well, again, that's similar to the log base a of 1. That's equal to 0. So that's 0. The natural log of e. Well, again, rewriting it as the natural log base e of e. That's very, very similar to property 1. That should equal 1 there. So the natural log of e to the x, that's similar to property 3, where it's log base a of a to the x is equal to x. Same thing here. And because e and the natural log are inverses, I know this fourth one is x also. Okay, so now I want to be able to simplify these two. So the natural log of e to the 5th, well, again, from property 3, we know that's 5. Okay. So e taken to the natural log of 3, because again, e and the natural log are inverses of each other. I know this answer is going to be 3.